So, one of the other things that is vitally important in looking at in a real world scenario is PTP timing. So, you can have the system be PTP timed, but what about your SDI network? Your SDI network and your PTP network need to be timed to the same exact timing source and the same exact starting point, because at some point you're going to want to switch between your IP network, your 2110 network, and your SDI network. And you need to be able to switch between those two sources and have everything perfectly synced without going through a complete reclocker. There's no need for it. So the starting point of black is line 0, pixel 0, right here at the top, up here, my 0 by 0. Well, PTP should be at the same exact point that black burst is. So when you look at your IP input and you look at timing, and you're referenced against black, it should come up with 0 by 0. Now, your horizontal offset is never going to be absolutely 0, and your horizontal offset is going to walk just a little bit. And the reason it's going to walk just a little bit is we're dealing with packets and switches. And a switch is a statistical multiplexer. And what it's going to do is at some point, a packet's going to show up. When multiple packets show up at the door and need to get out, the switch is going to statistically say, hey, this packet goes out first, you go right behind him. And at some point, PTP may go out first, or video may go out first. And packets get in front of other packets, and packets get behind other packets. So there's always just a little wobble in what's happening. What we're really worried about is the data that's inside of that to actually remove that little bit of wobble. But your horizontal offset, you are going to see just a little bit of movement in it. The thing that we're really interested in is, where does my 2110 video actually start? Because since in 2110 we don't send the vertical or horizontal intervals, we just send the active live video shown here in green. If you're a 1080i system, you know that your vertical interval is 21 lines. So my video for my 2110 system should start 21 lines later. And if you notice here in this particular instance, and this is real off of the live system here, it was 20 lines out, not 21 lines out. And I have not seen a standard that says it has to be this or has to be that. What I have seen from just real world working on this for almost 15 years is looking at the timing and what systems will withstand. And it's basically plus or minus about 2 lines. So if you're within about 2 lines here on the offset, you'll be absolutely fine, because the data will tell it exactly where to start. The other thing we need to make sure is that when we have a red-blue network or an amber-blue or AB, whatever you want to call the 2 links, that the timing between the one link and the other link are identical to each other, since they're being fed from the same SPG at the very top of the stack and being spread out to both sides of the switch, that everything follows suit all the way through, and your timing on both sides of your network are correct.
So this is a humorous way of saying do not begin your IP migration by touching the live core. Start in a controlled environment, learn the timing behavior of your devices, and prove your assumptions before you scale. A lot of first projects struggle because teams buy 2110 capable gear and assume interoperability equals production readiness. In reality, boundary clocks, endpoint behavior, multicast controls, NMOS, and failover behavior all have to be characterized. So the advice is to treat ST2110 adoption as an engineering program, not a feature enablement exercise.